Hey guys, thanks for joining me again for another episode of my YouTube channel, Long Live the Brains. Today I'm going to introduce a topic with a question. So think of a person that's had a stroke, and that stroke has affected their ability to perform some kind of function, but over the course of several months, years, they're able to regain that function. So how does that happen? It's not that the area of the stroke or the damaged brain tissue is, reborn or regenerated. It's actually because of the brain's ability to form new connections to allow it to be able to perform functions that have been lost. And this is a concept known as neuroplasticity, which is really the brain's ability to change and adapt over time so that we can more efficiently perform various functions. So there's a lot of research that has gone into neuroplasticity, and I just want to talk briefly about a couple of concepts so that you can kind of understand it, because I will be referring back to neuroplasticity in subsequent videos. So remember from some of the earlier videos that I talked about neurons in the brain, one of the major cell types within the brain. And these cells have wire-like projections that reach out to other neurons but don't quite touch them. And that space between two neurons is known as the synapse. So if you think about the neuron that's sending a signal out, that's an electrical signal traveling along that wire-like projection, and then it gets to the synapse. And at the synapse, neurotransmitters or chemicals that we've talked about in the past, like dopamine or glutamate, are dumped out into the synapse, and they float across, and then they're picked up by specific receptors, kind of like a baseball being caught by a baseball glove. And once those receptors are able to communicate with their neurotransmitter, that causes a change in the receiving neuron or the postsynaptic neuron, and then an electrical signal is then carried throughout that neuron, and then you go into the next neuron. So you've got electricity, and then a synapse, and then electricity, and then a synapse. And these connections are all throughout the brain. Now, as I mentioned earlier, in the case of loss of a function, say a stroke or a neurodegenerative disease, it's not so much that the brain forms new cells, although there are some brain regions that we do believe neurogenesis occurs in. It's really more forming new connections, new synapses with different places, and also strengthening the synapses that we have. So this is a process known as long-term potentiation, where these synapses can actually get bigger. And that when a synapse becomes bigger, there's more space for receptors to pick up neurotransmitters. So as those synapses become bigger, they become stronger, and we'll sometimes say neurons that fire together wire together. And that's because the more that a synapse is being used, meaning the more that presynaptic neuron is firing and trying to talk with the postsynaptic neuron, the more of a chance there is for that synapse to get bigger and bigger and bigger. It's like paving a back road or turning a back road into an interstate. Now, we know that there are lots of different factors that facilitate this process, and so you may see in the news or read about things like BDNF, or brain-derived neurotrophic factor, or GDNF, glial-derived neurotrophic factor. These are some things that I may mention in subsequent videos, and so I want you to have this video to come back to and look at as a reference.